Hello students. So today we will discuss about classification of crystalline solids. Solid state lecture 3. So as we discussed in previous lecture, crystalline solids and amorphous solids, main difference between them is arrangement of their constituent particles. Because of regularity for a long term, crystalline solids gives specific type of properties which shows regularity, while amorphous solids have irregularity and they shows short term order of arrangement of their constituent particles. So now from this point onward we will discuss about crystalline solids only. So as we can see, our first point for crystalline solid is classification of crystalline solids. Most of the things around us are crystals. We are surrounded by different type of crystalline solids. They may be metallic or they may be non-metallic. As for example, metals like Fe, that means iron, silver, gold, platinum, or metals which we use daily like aluminium, mixed metals or alloys like steels, these are metallic solids. And non-metals like iodine, sulfur, phosphorus, etc., these are non-metals and all of them are crystals. So we will discuss about classification of crystals or crystalline solids and their characteristic properties. And crystalline solids can be classified on the basis of nature of intermolecular forces operating in them into four different categories. That means we can categorize them on the basis of attraction between their constituent particles. These four main categories are molecular solids, ionic solids, metallic solids, and covalent solids. So step by step we will discuss about them and their some properties. So our first point, molecular solids. So as the name suggests, constituent particles of these type of solids will be molecules. That means they are made up of molecules. And as we know, we have some different type of molecules around us, and based on their nature we can categorize their solid states. So as we can see, in molecular solids we have some sub categories. As we can see, we have non-polar molecules, polar molecules, and hydrogen bonded molecules. So as the name suggests, based on their interaction or intermolecular attraction, these molecules are categorized, and according to these molecules solids are categorized. So our first subcategory, non-polar molecular solids. So as the name suggests, in this category we will use non-polar molecules like H2, I2, CO2, CCl4, etc., or some unimolecular species like argon. So these type of non-molecular polars have weakest attraction between them, which is London forces or dispersion forces. So they have weakest attraction between them. That's why their physical nature is very soft. That means if you have them as a solid, it will be very soft solid. They are insulator by nature, and their melting points are extremely low. As for example, suppose if we take example of H2. So normally at normal temperature it is present as a gas. Other example, I2, it is also present as a gas at normal temperature. CCl4 like compounds or argon like compounds, elements, all of them are gaseous at normal temperature. That means first you have to decrease the temperature to convert them into liquids, then you have to again decrease the temperature even more to convert them into solids. So that's why their melting points are extremely low. Attraction, main point is attraction between them. So as the attraction decreases, melting points also decreases, and London dispersion force is weakest intermolecular attraction. We already learned about this type of attraction in previous standards. Now they are insulators. So generally conductivity depends on two things. If one of them is present, then compound is able to conduct electricity. So first point is ions, free ions. if compound contains ions and if these ions are able to move freely, then it can conduct electricity. Second requirement is electrons. If compound contains free electron, that means electrons which are able to move freely, or single electron that is not paired with second or other electron. If one of these two requirement is fulfilled, then compound can conduct electricity. That means either we need free electron or we need free ion. If any of these is present in compound, then compound will be conductor, otherwise it will be insulator. So as we know, in this case none of these two conditions are fulfilled. That means we do not have free electrons or we do not have ions. So that's why these type of compounds will be insulator. So conductivity point will be applicable for all of these compounds. Okay, so same point will be discussed in next points as well. So let us move on second molecular solid. It is polar molecular solids. So as the name suggests, it contains polar molecules. So polar molecules have dipole-dipole interaction between them. It is comparatively stronger than London dispersion force. So that means these type of molecules will be slightly more attracted towards each other. So still attraction between them is too low that it do not absorb easily. And in normal condition, it will be soft, or mostly it will be present in gaseous state, but slightly more attractive towards each other than non-polar molecules. So dipole-dipole attraction is comparatively stronger than London dispersion force. As for example, if we have two different particles or atoms attached with each other and they forms molecule, then polarity arises, then it will be produced between them. One of the most common example, HCl. So as we know, hydrogen is partially positive and chlorine is partially negative. That's why HCl molecule will be polar molecule. And between two different HCl molecule, dipole-dipole interaction will exist. But still this attraction is comparatively very poor. That's why normally HCl, pure HCl is in gaseous form. We use HCl as a liquid form, but it is actually solution of HCl in water. It is called hydrochloric acid. And HCl normally it is gaseous by physical state. So that's why they are soft, because they have comparatively poor attraction towards each other. So as discussed earlier, they are insulator by nature because they do not have free electrons or free ions in them. They are molecules and all of the electrons are paired up in them, and no free ions are available. They have comparatively weak attraction between them. That's why their melting points are low, but it will be comparatively more than non-polar molecules. Next point is hydrogen bonded. As we know, hydrogen bonding is a one type of dipole-dipole interaction, but if sufficient strong electronegative element is present, then it can produce hydrogen bonding with second molecule. And these sufficient strong electronegative elements are fluorine, oxygen and nitrogen. These three are most electronegative elements, and if one of them is attached with hydrogen, then these type of molecules will produce hydrogen bonding. It is comparatively stronger, but still it is weaker than normal bondings. It is still intermolecular attractions, and all of the intermolecular attractions will be comparatively lower than bondings. That means covalent bonding, ionic bonding, or coordinate covalent bonding, or metallic bondings. It will be lower than that. But slightly stronger attraction arises. That's why these type of compounds are hard by nature. Still we do not have free electrons or free ion. That's why they are insulators, and their melting points will be comparatively low. As for example, water in form of ice, that means solid H2. Next point, our second type of crystals, ionic solid. So as the name suggests, constituent particles will be ions. So they are made up of ions, and ions have two different charges, positive and negative. So when we have opposite charges, and if we place them close to each other, they will attract each other strongly. This type of attraction is called Coulombic or electrostatic attraction. That means attraction between two opposite charges. These type of compounds, physically they are hard because they have comparatively stronger attraction between them. Coulombic or electrostatic attractions are comparatively stronger, but they are brittle. That means they are not flexible. If you try to bend it, it will break. They are hard but brittle. Insulation, that means conductivity of electricity or heat. They are insulators in solid state. Conductivity, so conductivity of this type of substance are different, slightly different. Normally in solid state, ionic solids do not conduct electricity. That means if you have pure water, normally it do not conduct electricity, but conductivity observed in water is due to ionic solids dissolved in it. If you have pure solid of this type, as for example, let us consider example of NaCl. Suppose you have NaCl in solid state, it won't conduct electricity, no conduction will be observed. But if you dissolve this compound NaCl into water, then it will conduct electricity. That means salty water will conduct electricity because of presence of ions. So as discussed earlier, conductivity is because of either presence of free electrons or presence of free ions. So as in this case, we can see if we have solid NaCl, then ions are not able to move freely. That's why they are not able to conduct electricity. But if you dissolve them in liquid, then they are able to move freely, and that's why they will conduct electricity. Same thing will be observed in molten state. That means if you heat this compound and melt it, then in molten state their ions are able to freely move. That's why it will conduct electricity. So that's why these type of compounds, normally in solid state they are insulator, but in molten or aqueous state they will conduct electricity. Their melting points are comparatively high because of stronger attraction arises between them. And as for example, NaCl, MgO, etc. You can use any other example which is known to you. It is not compulsory to use example mentioned in textbook. You can use any other ionic solid examples. Next thing, metallic solids. So constituent particles are cations in sea of delocalized electron. Now what it means? So it means metallic bonding. How metallic bonds arises? So let us understand using this figure. So let us assume we have three separate atoms of metal. They are not attached with each other right now. Let us assume these are sodium atoms. So as this inner circle represents, it has at the center it has 11 protons and 11 neutrons, and this inner circle represents it has 10 electrons, and outermost orbital or valence orbital contains 1 electron. So it represents Na plus ion with valence electron. So we have three separate electrons here, three separate Na plus molecules, as you can see in this figure. So these are positive ions present between them, and these are free electrons, delocalized electron. That means now this electron, which belongs to first atom of sodium, can move in orbital of second or third, etc. Any of the molecule it can go. So it represents it is delocalized now. That means it is not attracted towards a single nucleus. So suppose you have thousands of molecules, atoms like this. So all of their electrons will be moving around all of these nucleuses. That's why it is called cations in sea of delocalized electron, and it normally represents metallic bonds. So that means in metallic solid we will see metallic bonds. They are hard but malleable and ductile. Now malleable, that means by hammering or by applying force we can convert them into flat plates or thin plates. And ductility, that means by stretching you can convert them into wires. We know that we can obtain metal plates by hammering it, or we can obtain metal wires by stretching it. So it is the specific nature of metals, that means they are malleable and ductile. They are good conductor of electricity. As mentioned earlier, either we need free electrons or we need free ions. In this case, we have free electrons, and that's why it is conductor in molten or solid state. They have fairly high melting point because stronger attraction between. As the number of delocalized electron increases, attraction also increases. So higher number of valence electrons in metal gives stronger metals. Example: iron, copper, silver, gold, etc. Our last point is covalent or network solid. So as the name suggests, in this case you will notice covalent bond is present between the constituent particle, and as a constituent particles we have atoms. So atoms forms this type of covalent or network solid, and these type of solids are strongest one because they do not have any attraction between them, but they have covalent bondings between them. That's why they are hardest material, natural material obtained. As for example, diamond, they have very high melting point because of permanent covalent bonding present between them. They are insulators because they do not have free ions or free electrons present between them. So as for example, diamond and SiO2. But we do have exception in this case, and it is commonly available compound graphite. We know that we use graphite in pencils. Tip of pencils are made up of graphite, and as we know, it is not hardest material, okay, because we can easily sharpen it using sharpener. So that's why graphites are soft and conductor of electricity. Why they are exception, we will discuss about it. So as you can see, this is the structure of graphite. So graphite contains carbon atoms, and all of the carbon atoms have 3 bonds in graphite. As we can see, each and every carbon atom has 3 bonds only. So we know that normally carbon needs to form 4 bonds, but in this case it has only 3 bonds, and that's why it has one single electron, which is not seen in other covalent or network solids. So this is the reason why graphite can conduct electricity, because of presence of one single electron per one carbon atom. So suppose if you have 1000 carbon atoms in graphite, then you have 1000 single electrons for conduction of electricity. So this is the reason why graphite is conductor of electricity. Now next thing, why graphite is soft. So as you can see in this figure, we have two different graphite plates. They are sliding on top of each other. Reason for that is, as we know, each carbon present in graphite contains 4 electrons, but 3 of them is bonded with adjacent carbon, but 1 electron is still single. So this single electron will try to attract single electron of second graphite plate. That's why two different graphite plates will be attracted towards each other. But it is not permanent bonding. That's why they are able to freely move. Still, they will feel attraction. So this is the reason why graphite is soft. It is soft because it can slide on top of each other. Two different graphite plates can slide on top of each other. This is the reason why you can write with pencils. If you are trying to draw or write something on top of the paper using pencil, you are actually sliding different plates of graphites. And that's why graphite is also used as a solid lubricant. That means it is used to decrease the friction. So if you have any confusion or doubts regarding to these topics, you can ask me. Otherwise, we will meet in next lecture. Thank you.